Hey guys, welcome back. Today we are going to be going through a dilutions worksheet and doing a little bit of practice using our dilution formula. So the first thing we are going to do is grab our highlighter, and we are going to highlight using the color blue today because I feel like it. And we are going to highlight any of the important information in the question. It's a very good habit to get into, so let's start off by doing that. So if we look at question number 1, if I add 25 mils of water to 125 mils of a 0.15 molar solution, what will the molarity of the diluted solution be? So they are the four main things that we need to kind of keep our eye out for. So along the side over the edge over here, we're going to do our C1, V1, C2, V2. And we are going to just fill that in. This is just writing down the information we have in a very clear and easy way to see. So first off, our starting solution is going to be this information here. So we're starting with 125 mils. So 125 mils of a 0.15 molar solution. So 0.15 molar. And we'll just put the little N there. And it doesn't really matter that it's sodium hydroxide at this point, so we're not going to be concerned about that. We are trying to find the molarity, so we're trying to find C2. Nope. Well, let me do dots. And I am adding 25 mils. So if I do, volume 2 is going to be 125 plus 25, which is 150 mils. And hopefully that all makes sense up until this point. So that is all the information we have been given. Once we've got that, we're then going to write down our formula for the actual dilution calculation, which is C1 V1 equals C2 V2. And of course there's like imaginary little multiplied signs in between there that you don't have to write, but they still exist. So we've got that written there. Then we're going to just input our numbers. So concentration 1 is 0.15 multiplied by the volume 1, which is 125, equals X multiplied by 150. That is a 0. Don't mind the messiness of that 0. Once we've done that, we're going to rearrange the equation. So the way that we do that is this number over here is going to be divided on both sides. So both sides are going to be divided by 150. 150, something multiplied by 150 divided by 150 cancels out the 150. So we end up with 0.15 multiplied by 125 divided by 150 equals X, and then that means X is going to equal the answer of our calculation, which when we actually put that into the calculator, 0.15 multiplied by 125 divided by 150, that is going to give us 0.125 molar. So that is our answer. The concentration will become 0.125 molar. There we go. So I'm just going to grab myself a highlighter, and we are going to, just the yellow one, just highlight the answer so we can see where that answer is. So it's nice and clear. So our answer for what molarity will the diluted solution be? It will be 0.125 molar. That is the answer to question number 1. Moving on, question number 2. We're going to do the same steps as before. We're going to grab our highlighter and read through the question, highlight anything important. So if I add water to 100 mils of 0.15 molar sodium hydroxide solution until the final volume is 150 mils, what will the molarity of the solution be? So then that's what we're finding. So again, C1, V1, C2, V2, and we're just going to write down the information we know. So we're again trying to find the concentration 2, so we don't know that one. We know the start solution is this information up the top here. So the start concentration is 0.15 and the start volume is 100 mils. And the final volume we know is going to be 150 mils because it tells us that. Now, in a lot of calculations, I constantly tell you change everything into liters. But in this case, and the last example as well, because they're both already in milliliters, and it's one of them is like on either side, it cancels each other out. So it doesn't matter if it's in liters or milliliters or whatever, as long as they're both the same. If it was in one in liters and one in milliliters, you might as well convert it to liters. If the question was asking you what would the volume be in liters, then you might as well just change it to liters. It's up to you what stage you do it, but it would make sense to just do it at the start. Hopefully that made sense. All right, so we're going to go through C1 V1 equals C2 V2, and we're going to start by just inputting our values. So 0.15 multiplied by 100 equals x multiplied by 150. Then we rearrange our equation, so we're just going to write this part out again. We are going to divide both sides by 150, so 150 is cancelled out on that side and place down the bottom over there, and then we put that into the calculator. So 0.15 multiplied by 100 divided by 150 gives us our answer, x equals 0.1 m, which means our molarity is 0.1 moles per liter. I'm hoping this will make sense. It's a pretty straightforward, easy to do equation, so hopefully it's not causing any issues. Alright, let's move on. Next question. How much 0.05 molar hydrochloric solution can be made by diluting 250 mils of a 10 molar hydrochloric acid? So if we go through this time, this information here is our start information, and this is what we want to end up with. So let's write that down. C1 V1 C2 V2. So we are now looking for how much of something. So that means we're looking for the volume. The concentration 2, the one that we're going to end up with, is the 0.05. And then our start concentration and volume is 10 molar and 250 mils. Alright. So it is kind of important to make sure that you have this information over on the left written down, so that you don't get confused leading things left to right. Oftentimes people will then put the 0.05 molars as the start concentration, when it's not. It's the end concentration is what you're trying to end up with. So that's kind of a very important step to make sure that you're following that. Alright, so C1 V1 equals C2 V2. And then let's start by inputting our information. So 10 multiplied by 250 equals 0.05 multiplied by x. And same thing as before, we're going to now divide by the 0.05 on both sides, which cancels that out on the right, but leaves it on the left. So our rearranged equation is 10 multiplied by 250 divided by 0.05 equals x. And when we actually calculate that, x will end up equaling a very large number, which will be 50,000 mils, or to make it a much easier number, 50 liters. And then we're just gonna highlight that to make it clear that that is our answer. Alrighty, next question. We are smashing this out. Question number 4. I have 345 mils of a 1.5 molar solution. If I boil the water until the volume is 250 mils, what will the molarity of the solution be? Alright, so starting again off to the side, C1 V1 C2 V2. This formula is going to get stuck in your head for the rest of your life. You're never going to be able to get it out. Which is probably a good thing. If you don't remember anything else, at least you'll be able to concentrate a dilution. Or calculate a dilution. So we've got a concentration is 1.5 moles, volume is 345, and that's in milliliters. Second volume is 250 milliliters, and then our concentration we're trying to find. So C1 V1 C2 V2, and same thing, we're going to do 1.5 multiplied by 345 equals x multiplied by 250. And then we write down our next step of the equation. 5 divided by 250 equals x. And then put that into the calculator. 1.5 multiplied by 345 divided by 250. X equals 2.07 moles. And you can have a look at this and see, okay, well, is it making sense? So If I'm decreasing the amount of water in the solution, should the concentration be going up? Yes. So the fact that it went up makes sense. You can also kind of have a look at it went down by about 100 mils, which is almost a third-ish. Would it make sense for it to go up by just a little more than a quarter? Yeah, it would. So it kind of makes sense. It's going up in a pattern that we would expect. So I'm not too surprised by the answer. If this number went down, when the volume went down, you'd know you have the troubles. You're doing something wrong, and you'd probably need to consider what did you do wrong and how do you fix it. So it's important that you're checking your work and just looking, does it make sense the way that it's working out? And if not, redo the equation, recalculate it, because it's most likely a calculator error, or you've written something wrong. Hopefully that makes sense as well. All right, let's smash out this last question. How much water, so this is a volume question, would I need to add to 500 mils of a 2.4 molar solution to make it a 1 molar solution? All right, so you know the drill by now. C1, V1, C2, V2. So concentration number 1 is 2.4. Volume number 1 is 500 mils. And then concentration 2 is 1.0 molar. And our volume 2 we are trying to find. So C1, V1 equals C2, V2. That was a very weird looking V. 2.4 multiplied by 500 equals 1 multiplied by x. So 2.4 times 500 divided by 1 equals x. X equals, what's 2.4 divided by 500? 1.2. No, 1,200 milliliters. So the question is asking, how much water would I need to add to 500? We've found out what the final volume will be, which is 1,200 milliliters. So in order to work out how much do we need to add, our final step for the answer is 1,200 minus the original start value, which is 500, equals 700 mils. So the answer to our question is actually, that's a very bad therefore sign. The answer to our question is actually 700 mils, because our end volume is going to be 1,200, and we need to work out how much you need to add to get to that, which is 700. I hope that makes sense. And yes. So that's the answer to all of those dilution questions. I hope that makes sense to you. If you have any questions, don't be afraid to ask them, and let me know how you're going with these. So I hope you liked the video, and I shall see you in the next one. Bye bye.